Compare that to an end mill holder that can also... Hello Internet, my name is Quinn, and this is Blondihacks. This is a video all about collets. This is one of those videos that when I was starting out I wish had existed, because collets seem like such a vast and bewildering topic in the machine shop. There's so many types, there's so many sizes. What do you need to buy? Let's find out. Fundamentally, a collet is a way to hold something round, not always round, but usually round, in a very accurate and repeatable way. The reason that we use collets over something like a chuck for work holding is typically because you want maximum concentricity, which is to say the lowest possible runout, and you want something repeatable. Collets give you the ability to remove the part and put it back, and you're not going to lose concentricity or increase the runout substantially in that part. What I have here is 3 extremely common collets that you'll likely encounter, and one very exotic one that you will probably never see again. This is an ER collet. These come in multiple size categories, so all of the sizes of collet come in different size categories, which indicate the overall size of the collet itself. So there's ER16, ER32, ER40, and there are some smaller ones and larger ones as well, but 16, 32, and 40 are the most common ones. This is an ER32. Not every size is, of course, available in every size category. The overall physical size of the collet limits the dimensions of what it can hold. So you're not going to find a 1-inch diameter ER32 collet, because that's simply too big for a collet this size. The hole would leave no material around the collet. This is a 5C collet, another extremely common type. You might also encounter its little brother, the 3C collet, but they're very similar. Again, just different size categories of the same style of collet. And then finally we have the R8 collet. Again, a very, very common style of collet. The only difference you might see in these is they do have a couple of different threads in the back, which we'll talk about in a minute. On the right here is a decal collet. This is a truly exotic collet that you are not likely to encounter unless you have a vintage decal or Coolman D-bit grinder, and well, if you have to ask what these cost, you can't afford them. Now, of note here, I've chosen a 1/2-inch size in all of these collets. All of these will hold something a 1/2 inch in diameter, but you can see how different they all are. The reason there are so many types of collets and why they all look so different is because they all have slightly different trade-offs involved in them. There is no single perfect collet, and so each of these collet styles has different pros and cons that go with it. And that's why there are so many, and that's why you are certainly going to need to have more than one type. The most obvious difference is between these two styles, the ER and the 5C. You can see that this is what's called a single cut collet, and this is a double cut collet. What that means is when you clamp down on something in this collet, the collet is only flexing at one point. There's a series of cuts around this collet, and they're all starting down here. So when you close down on this collet, only the front edge of this collet is closing down, and the whole thing is essentially hinging back here. What that means is, with a single cut collet, the work is only being gripped at the very front edge. Even though the collet is really long, and when you put your 1/2-inch stock in here, it's going to feel like it's gripping all the way down the length of this collet, it isn't. Only the very front edge of that collet is gripping. So in a sense, that's a disadvantage of a single cut collet. The other key disadvantage of single cut collets is that they can't flex very much. Otherwise, this angle where it's hinging gets too large effectively. What that means is whatever you put into a 5C collet has to be very, very close in size to the collet. A 5C collet can't hold anything bigger than the indicated size, and it can only be 2 or 3 thousandths smaller than the indicated size. So these things are not very flexible, literally and figuratively. That seems like a lot of disadvantages to single cut collets, so why would you want them? Well, first of all, they are cheaper, so it's easier to have more sizes, but there are some specific use cases for which single cut collets are more useful. Most notably, they are rear closing collets. All collets have a closure method for them, which is to say they have tapers on them, and the taper has to be drawn into a matching taper, and that's what compresses the little grippy jaws or the wings of the collet. There's different ways of doing that, hence all these different collet styles. The 5C collet is a rear closing collet, which means the collet is drawn into a matching taper, and that's what closes up the gripping taper at the front. There are many work holding setups where a rear closing collet is advantageous because it gets the tooling out of your way, and it means you can get cutting tools very, very close to the front of the collet because there's nothing up here that's obstructing your access to the stock. You can work right up to within 1/1000th of the nose of this collet because all of the closing hardware is back here somewhere, usually in the form of a drawbar or a draw tube. 5C collets are also through collets. Not all collets are, but through collets allow you to pass long pieces of stock all the way through them, so you're not limited by the depth of the collet. And the other little trick up their sleeves in 5C collets is that the rear of them are double threaded. There's a thread out here, and there's a thread in there. These threads can be used for different things. Typically, the collet closing mechanism uses the outside thread to grab onto this and pull it into the closure. But then this inside thread is frequently used for a collet stop. So you can thread something in here, an adjustable length bar, such that when you push workpieces in, they will all stop in the same place. They'll hit the collet stop inside. And this is excellent for mass producing parts. If you have to make a lot of something that are all the same length, you can put this collet in your machine and it's going to repeat on this axis every time you pull stock out and put it back in because you've got that collet stop hiding in there. 5C collets are the only collet style that allow you to put a collet stop inside them. So that's a really strong reason to own these guys. Next up are the double cut collets, the ER series being sort of the poster child of this style. This is the most likely form of double cut collet that you're going to encounter. Now it looks like there's slits all the way along here, right? But if I put a light behind it, you can see that every other slit is going the opposite way. So this slit is hinged at the bottom, but this slit next to it is hinged at the top. So this slit is cut from here, and this previous slit was cut from the top. So every other slit is cut the opposite way. And that confers a couple of key advantages. You can imagine those slits working together as kind of like an accordion. So what that means is that the gripping sections of the collet can move further apart because they have more range of motion. They've got 2 slits for every segment, so you get more range of motion than you do from a single cut. And even better, because you've got that double cut action, the sides of this collet are closing more or less parallel. Instead of being hinged and closing at an angle like on a single cut collet, these collet segments are moving mostly parallel to each other. So what that means is they can grip all the way down their length. And then that increased range of motion means that you can be further from the nominal size of the collet and these things will still work. So your work can be 40 or 50 thousandths smaller than the nominal size, and an ER collet can squish down that far and still grip it because of that increased range of motion that the collet segments have. ER collets are also front closing collets. You'll notice that there's 2 tapers on them, and the collet closer for an ER collet always works from the front rather than the back. So an ER collet is pushed into the closure rather than being drawn into it from behind. Now that can be an advantage or disadvantage depending on the situation. This is a very typical ER collet closer that I have on my lathe. The collet nut, as they say, has a small taper in the inside of here, and that taper matches the little taper on the collet. And then the base has a large taper in it that matches the large taper on the collet. So when you install this guy in the collet nut and then screw it in to the base, as we tighten this down, the collet nut is compressing the small taper and the base is compressing the large taper. So both those tapers are getting compressed, and that's closing both of those double cut segments in a parallel fashion against the work. Now this big collet nut, while convenient because it's on the front, does cost us a little bit of real estate. You can't get quite as close to the work as you typically can with a 5C collet. So you will also see 5C collet chucks on lathes where there's a draw tube typically that runs through the spindle and the collet is drawn in from the back all the way through the spindle. Or you will also see 5C collet chucks that are fairly large and they have the collet drawing mechanism entirely inside them. And as I said before, 5C collets are also great on lathes because of that collet stop feature inside the collet. Any collet can hold a workpiece or a tool. I've been assuming workpieces so far, but let's talk about the R8 collet now, which is the most common type of tool holding collet that you're likely to encounter. There's no rule saying you can't also hold work in these, but typically they are used for tool holding because this style of collet is specifically designed for the R8 taper that you find in Bridgeports and most other common milling machines these days. Now there are a lot of milling machine tapers in the world, but for the small and medium-sized mills that you're typically using in a hobby shop, you've probably got an R8 taper in it. And if you're shopping for a mill, you really do want one that has an R8 taper in it because R8 tooling is extremely common, inexpensive, and easy to get. The main distinguishing feature of an R8 collet is that it is not a through collet and it has a drawbar thread in the back. So similar to a 5C collet, it's designed to be drawn in from behind, or in the case of a milling machine, from above, and it is a single cut collet, so it has all of the limitations that go with a single cut collet. The main reason these exist, since they're so similar to 5C collets, is because the taper angle on them is specifically optimized for tool holding. This is a self-locking taper as opposed to steeper collet angles, which are self-releasing. You can feel this on your milling machine when you release the drawbar to get your tool out. That collet is often stuck in there and you have to push down or tap down on the drawbar to push that collet out because it doesn't want to come out. That helps hold your tooling. Whereas 5C collets, when you release the collet drawbar or whatever's holding it in there, it tends to pop itself out automatically. A self-holding taper is really useful in a milling machine because otherwise you need 3 hands to remove and install your tooling, because you have one hand on the drawbar and you've got one hand on the spindle wrench keeping the spindle from turning, and then you loosen those, and if this was a self-releasing taper, it would pop out of there instantly and your tool would fall out, damage the tool and probably your work. However, because it's a self-holding taper, you can break loose the drawbar, and then that frees up one hand, your spindle wrench hand, to go put on the tool and continue releasing the drawbar while you hold the tool with your hand. And since it's here and they're interesting, I'll talk about the decal collet. By now you should have all the information you need to identify what kind of collet this is and what the use cases for it are. It is a single cut collet, it has a self-releasing taper, and it is a through collet, so it's going to be used in similar situations to a 5C for many of the same reasons. This style of collet is specifically for holding workpieces in decal D-bit grinders. The main distinguishing feature of it, aside from the length, which is helpful for getting into the workhead in the decal, is that it has a buttress thread on it, which is a very unusual thread you don't see very much. A buttress thread is flat on one side and 60 degrees on the other, so it's very, very strong when pulled tight in one direction. And that was just, a little bit of extra German engineering there that they felt was necessary. Let's talk more about using collets specifically for tool holding, because there's some interesting pros and cons there as well. As I said, the R8 collet, you're primarily going to be using it for tool holding in an R8 mill. So this being a 1/2-inch collet, I'm going to put, say, this 1/2-inch end mill in it. Now, that holds the end mill just fine once I tighten that down. However, you may have noticed, if you've looked through the machinery catalogs, that you can buy end mill holders. So a reasonable question is, why would you need or want an end mill holder versus just using a collet like this? Well, holding tools directly in a collet in the spindle is quick and easy, so that's the main advantage of it. However, there are a number of disadvantages to this. First and foremost, as you can see, I can place this tool vertically anywhere in that collet. If I have this end mill right here and tighten it down, it's going to have that much stick out. If I push it up here and tighten that collet down, it's going to have less stick up. What that means is tooling held in an R8 collet or any type of collet does not repeat on Z. It does not repeat on the depth or spindle axis. And that can be a big deal if you're doing a lot of repetitive operations where you're changing tooling in and out. Every single time you take a tool out of a collet, you've lost the longitudinal position of that tool. So if you need to get back to where you were, you're going to have to touch off on the work again. Now compare that to using an end mill holder like this, same 1/2-inch end mill. This guy goes in to this end mill holder to the same depth every time. And once this holder is installed in the spindle, it goes into the same depth every time. So this tool holding system repeats on Z. So I can pull this tool out, put it back in any number of times, switch out my tools, do different operations, and I never have to touch off on the work a second time, and all of my DRO spaces are all valid. My quill depth and my Z on the DRO are all going to remain accurate even when I change this tool in and out. The other reason you'll see end mill holders is on big heavy machinery with very large end mills taking heavy cuts. The collet may not have a good enough grip to hold up to those kinds of cutting forces. Collets are just using friction to hold on to the tool. However, end mills, especially larger ones, have these flats milled into them, and there's a set screw on the end mill holder. So you can tighten that set screw down on that flat, and that's a much more positive grip on that tool, and this can handle much, much more torque. Of course, in a hobby shop, this absolutely never matters. There is no hobby mill of the size you see on my channel that could ever possibly produce enough torque to overwhelm a collet. However, that is also why these exist. The main disadvantage to end mill holders and other styles of tool holder like this, and the reason that I don't recommend them in hobby shops, is that they add a lot of length. So if this was in the spindle, this is actually a Morse taper tool holder, so it doesn't go in the spindle on this machine. But if this was in my spindle, you can see that it's adding a good inch, inch and a half of length to the end of my spindle before you get to the tool. And that's costing you a lot of rigidity. Now on a big heavy industrial milling machine, that loss of rigidity is trivial compared to the other advantages of an end mill holder. So you're going to see people using these in industrial settings or with big machinery. But in a hobby shop, that inch of rigidity there is the ball game. Like, you really can't afford that inch of loss. The other thing this costs you, which is a big deal in a hobby shop, is Z real estate. Hobby milling machines tend not to have a lot of real estate in the work envelope in this direction. They typically have small coil travel, 2 or 3 inches, and typically not a lot of head movement. And then you've got a vise in here and your work and everything else. So again, this inch or inch and a quarter makes all the difference in the world on whether or not you can fit your workpiece into the real estate or the work envelope that you have in here. Z height is always at a super premium on hobby milling machines, and anything that costs you Z, you should think twice about. Another question that plagues the beginner is, how many collets do you need to own? How many sizes? Because you can buy these sets in all different ranges. Most collet sizes in the imperial world come all the way down to the 64th, and in fact, even the 1000th. If you dig into the machine shop catalogs like MSC Direct, you can buy a collet in any style in almost any size all the way down to the 1000th. So you can own as few or as many as you want and or budget and space allow. How many do you actually need? The unfortunate fact for your wallet is that with collets, more is always better, particularly with work-holding collets like your 5Cs and your ER collets. The more sizes you have, the more sizes of material you can hold. And remember, because of, especially with the 5C collet, that limit where the work has to be extremely close in size to the nominal dimension of the collet means that you really do need a lot of sizes. What I have here is a standard 5C set by the 16th. So 16th, 8th, 3/16, etc. Every size by the 16th, all the way up to inch and an eighth, which is the maximum size you can get in a 5C collet. And this I would consider the absolute minimum of a 5C collet set. As I said, you can get them all the way down to increments of the 64th, or even smaller if you're willing to shell out really big bucks. The less commonly used a collet is, the more expensive it is. So half-inch collets are a lot cheaper than 11/64ths collets or 197 thousandths collets. So you can buy a set like this reasonably inexpensively, and then maybe supplement it with the weirder sizes as you find yourself needing them. For tool holding collets, or primarily tool holding collets like the R8, you don't need nearly as many, for the simple reason that tooling comes in standard sizes. Here in the imperial world, 90% of my tooling is half-inch or 3/8, so a very small set of R8 collets like this is extremely adequate. I've very, very rarely needed a collet in any size other than these. While we're in here, an alternate form of tool holding that is popular with hobbyists is to use ER collet closers like these guys with small collets. These closers have a straight shank on them, which you can then hold in a dedicated R8 collet that lives in your spindle. And the end of this special R8 collet is precision ground, so the whole assembly repeats in Z. So you get the advantages of Z repeatability while still holding your tools in a collet, because the tool never leaves the collet. You take the entire assembly out each time. The main reason you don't see me using this system, even though I do have it, this was actually a gift from a viewer, I don't tend to use it much because of, again, the cost in Z real estate and the loss of rigidity. But those are my personal preferences. Very, very many hobby machinists use a setup like this, and it works super well for them. So it's definitely worth considering. And these individual per tool collet holders can be purchased relatively inexpensively on eBay or some of the discount import tool companies. No discussion of collets would be complete without discussing collet blocks. These are some of the most useful things you can do with collets, so you're definitely going to want a set of these. And these are really inexpensive. This set here that's for 5C collets comes with the square and the hexagon, and this is just one of those basic super cheapo ones that you can get everywhere, Amazon, eBay, wherever. I'm sure they're all the same kit, and they work just fine. So if you've watched my channel at all, you've seen me use these a lot. Collet blocks are incredibly useful. What they are is a very quick and straightforward indexing system. So once your work is in that collet, and that collet is tightened down either with the ring or with the quick release lever, whichever is more convenient, now you can index that part perfectly repeatably in the vise in your milling machine. The secret sauce with these is that every single surface on them is precision machined. So that gives you all kinds of references when you've got your work held in there. So for example, when I put this block in my vise, I can use any kind of straight edge to align the precision front surface of this block with the fixed jaw on my vise, which of course is the canonical reference on your mill. And now the X position of this collet is perfectly repeatable. I can do any kind of operations I want in the stock in this collet, and I can take it out, rotate the collet, put it back, change tools, whatever. But I know that every time I put it back in here and line up that edge, that material is in exactly the same place on X, assuming I haven't moved the piece in the collet. So it's much like an end stop on the vise, and it's very, very powerful. Then, of course, the most common use case you'll see probably for collet blocks is that they allow you to quickly machine the shape of the collet into the workpiece. If you want to cut a hexagon, put it in your hexagon collet block, and you make a series of cuts, rotating the collet block around like this, and you'll end up with a hexagon or a square. But you want to think bigger than that with collet blocks, because really what that's doing is indexing the part. So yes, you can cut a hexagon, but this is also a 60-degree indexing tool. So if you want to cut a 60-degree angle on a part, if you can hold that part in a collet, or if you can arrange the part to be holdable by a collet, you've got an extremely quick and accurate 60-degree angle reference. Similarly, the hex collet and the square collet both give you an excellent 180-degree reference, which is extremely useful. If you're cutting both sides of a round part, you want to remove the same amount of material off two sides of a part and end up with a feature that's still centered on that part. Again, 180-degree reference. The key to that is that when the collet is in the block, the workpiece is held extremely concentrically to the outside surfaces of that block. And that's why it can be used for indexing. Once you kind of wrap your head around that, you'll see all kinds of new uses for collet blocks that you didn't think of. They're not just there for cutting hexagons. I happen to have a 5C collet block, as I've shown you, which has the nut that draws the collet in from behind. However, you can also get ER collet blocks, which use a collet closer nut on the front, and they have a thread on the front of the collet block, just like I showed you on the lathe. I think both work equally well. I think the 5C collet block does have the same advantages in access as on the lathe that I talked about, where because the collet sticks out a little bit and there's no big closer nut on the front of it, you do have a little better access to the work really, really close to the collet. So you can make cuts extremely close into the collet, which is good for rigidity and also good for working on really small parts. Whereas with ER collets, you do pay a bit of a price for access and clearance around the collet by having that big collet closer nut on the front. Let's wrap up by talking about how to buy collets. You've no doubt noticed, if you've looked, they are very, very expensive, or at least they can be. If you go and try to buy a nice set of hard-inch collets, a really good quality set, you are going to need to bring your checkbook and possibly your mortgage statement. They are very, very expensive. The good news for the hobbyist is that the budget-friendly Asian-made collets that you can buy everywhere now are really very good. The quality of them has gone up so much in the last few years that I would say that the total indicated runout on them is typically only a few tenths worse than a really high-quality German-made collet, and they're 1/10 of the price. So for the home gamer, I think the value proposition is absolutely clear. Buy inexpensive collets, they are fine. Now, don't go too far. I would not buy random third shift sets that you find on eBay that are shipped directly from China, I would go to a reputable tool importer like Shars or KMS or KBC, MSC Direct, places like that where they curate their stock a little bit, so you're going to get an inexpensive collet that still meets a reasonable quality standard. Be prepared for a little bit of wastage. That set of R8 collets that I have, for example, the 3/4 size in that set was garbage and I had to replace it. So you might get the occasional bad one, but overall you're still going to save a lot of money by buying the inexpensive sets. The other advantage to doing that is that you can then afford a lot more sizes, especially for 5C. If you have more sizes, then you're going to get a lot more use out of them. And on that subject, if like many beginners, you're thinking, well, I'm just going to commit to one type of collet and use it for everything, you really can't. That said, Desert Island, if I only had one collet that I was allowed to have, it would be the ER collet, because you can use them for tool holding or work holding. You can get collet blocks for them. You can get tool holders for them for the mill, as I've shown in this video. And they are a lot more flexible, being a double cut and parallel grip style of collet. They have more range of size, so you can get away with not having quite as many intermediate sizes as you need with the 5C. So if you're just starting out in hobby machining and you want to buy one set of collets to begin with, I mean, if you have an R8 mill, you need to buy a small set of R8 collets, I think, for all the reasons that I've said. But aside from that, the next set of collets I would buy would be a modest set of ER collets, probably ER32. For hobby milling, small parts making like you've seen me do on my channel, the ER32s are a really nice size. The 16s are a little small, the 40s are a little big. The main reason that I have 5C collets is because when I was starting out, this video didn't exist for me to watch, and I didn't really understand all the different types of collets and why they exist. And 5C collets seem to be the most common and the least expensive, so I went with 5C. And in hindsight, I would have started with ER, knowing everything that I know now about collets. That said, I do enjoy having the 5Cs for the advantages that I've talked about, you know, the close access to work and the collet stop features that you can get for them and so on. But like I said, Desert Island, only allowed one type of collet, it's going to be the ER32. The other thing to know about inexpensive collets is that the way they make them so inexpensive is that they cut corners on the finishing. So you will need to do a little bit of massaging when you first get any of these budget collets. The primary way they cut costs on these is that they don't deburr or clean them after manufacture, because those are the steps that require labor, and labor is expensive. What you're going to find on them is typically there's going to be a bunch of grinding dust in them, and most importantly, there's going to be swarf trapped in the grooves or in the slits of the collet. And you got to get rid of that, because otherwise, if there's a piece of swarf in every 5th slit, then this thing isn't going to close down evenly, and you're going to have more run out in the collet than you expect. So if your inexpensive collets seem to have more run out in them than the specification or than you think they should, then hold them up to the light and really look through all of the slits and look for debris in those slits. To clean them, what I find works well is to take a folded up Post-it note, seems to be just the right thickness for this for whatever reason, and run it through those slots like so. A couple of swipes, and remember each slot is cut a different way, so you got to go the opposite direction from slot to slot, and swiping this Post-it note through there I find does a really good job of fishing out all of the burrs and grinding crud that they left in there. It's a little bit of extra work when you first buy a new collet, but considering you can get a collet that has 3 or 4 tenths of total indicated runout compared to the 2 tenths on the hard edge for 1/10 of the cost, a little bit of Post-it note labor seems worth it. That's my little spiel on collets. I hope this demystified them for you a little bit as a beginner. This is one of those topics that seems super bewildering at first, and machinists all talk about it like it's old hat because they don't even think about what it was like to not know all of this stuff about collets. But as you can see, there's really not that much to them. There's only a couple of key things you need to know, and only 1 or 2 types that you actually need to own. Thank you very much for watching. I hope you found this useful. Thanks to my patrons for making all of this content possible, and I will see you next time.